So on to chapter 11, and this section is about sequences. So sequence means that you've got a list of numbers. So maybe you've got like 1, 4, 7, 10. So that's the sequence of numbers. And then later, and the rest of the chapter 11, we're going to be doing series, which would then mean add them up. So for right now, we're just making the sequence of numbers, and then later on, from 11.2 on, we're going to be adding them up. So does this sequence converge or diverge? So converge means that as you have n go to infinity, then the little fraction, does it become just one number or not? So that's the main goal. With diverge, that means that it doesn't equal one number or it goes to infinity. So diverge has two possibilities. One is if you look at the numbers and you get something like 3, and later it's 7, later it's 11, and then it's going to be 15, and it just keeps getting bigger and bigger and going to infinity, then that's diverge. Also, if it gives you more than one answer, that's also diverge. So if it did something like 1, 2, 1, 2, 1, 2, well, this sequence cannot make up its mind. Is the answer 1 or is the answer 2? So both of these would be diverge. They don't give you one single answer. Okay, then on to this one specifically. So you could go ahead and plug in numbers yourself for the n, with n being, well, I guess you could even start with a 0 and then a 1, etc. Or you could use the calculator and then go to second list, move over to operations, and use the sequence. So this calculator right here is using the old-fashioned where I have to type it in myself. So put 4 raised to the, and right now my calculator is using t as the variable, which is perfectly fine. So that's the 4 raised to the t plus 1, and then divided by 5 raised to the t. Now the only thing is, when I get to this part, I then have to tell the calculator t is my variable. Start with a 0, and let's look at the first, let's say, 11 terms. So from 0 to 10, that's 11 terms. And we're going by ones. So these are the numbers, and if you look at the list and move to the right, you'll see that they're getting smaller and smaller. So it had started with a 4, and by the end of the list, it had gotten down to a 0.429. And then I could tell it, let's try that again, and what if you do 90 terms? And now I'm not sure if it's going to be easy to see, but if you follow the list out, you could see that the numbers just kept getting smaller and smaller until finally it switched to scientific notation. So it seems like these are becoming 0. You could also, okay, I'm going to have to change it back to normal mode, back to the function mode. You could also treat it as a function and say it's 4 raised to the x plus 1, and then divided by 5 raised to the x. And then if you graph that and you follow it out to the right, you'll see that it's becoming 0. All right, then how do we actually do that and show that the answer is going to be 0? So let me go back to the actual question. So for this, we can say, take the limit as n goes to infinity, and then what's happening with this fraction? Well, for one thing, I'm going to rewrite this as 4 to the n times 4 to the 1. And the reason for that is I can then see that we've got a 4 to the n and a 5 to the n. And I could rewrite that as 4 over 5 to the n, and then I could move this out in front. So there's two ways that you could do this. You could, if you go back to this step, you could do L'Hopital's rule. So take the derivative on the top, take the derivative on the bottom. Or you could do it the way that I did with the algebra, and now that we have it as 4 in front, so that's the a, and then this is basically r to the n, so that's a geometric sequence. So in section 11.2, we would actually add this up with this. It's just saying, does it converge? Since it's a geometric sequence and r equals the 4 over 5, well, the rule is if that's less than 1, it converges. So the r is 4/5, that's less than 1, therefore it converges. And the directions on this one just ask, does it converge or diverge? So this is my proof that it converges.